Good morning. My name is Kartikeyan Nenigan, 20 registration number 21BME1266. I'm going to talk about wastewater management. Wastewater. Wastewater is water generated after the use of fresh water, raw water, drinking water, or saline water in a variety of deliberate applications or processes. Another definition of wastewater is used water from any form of combination of domestic, industrial, commercial, or agriculture activities, surface runoff, stormwater, and any other sewer inflow or sewer infiltration. In everyday usage, wastewater is commonly a synonym for sewage, also called sewerage, domestic or domestic wastewater or municipal wastewater, which is wastewater that is produced by a community of people. Evaluation of wastewater. As a generic term, wastewater may also be used to describe water containing contaminants accumulated in other systems, such as industrial wastewater. Waterborne waste generated from a variety of industrial processes, such as manufacturing operations, mineral extraction, power generation, or water or wastewater treatment. Cooling water, released with potential thermal pollution after use of condensed steam or reduced machinery temperatures by conduction or evaporation. Leachate, re- precipitation containing pollutants dissolved while percolating through pores, raw minerals, products, or solids. Return flow. The flow of water carrying suspended soil, pesticide residues, or dissolved minerals and nutrients from irrigated topland. Surface runoff. The flow of water occurring on the ground surface when excess rainwater, stormwater, meltwater, or other resources can no longer sufficiently rapidly infiltrate in the soil. Urban runoff, including water used for outdoor cleaning activity and landscape irrigation in densely populated areas created by urbanization. Agriculture wastewater, animal husbandry wastewater generated from confined animal operations. Sources and types of wastewater. Sources of wastewater include homes, shops, offices and factories, farms, transport, fuel depots, vessels, quarries and mines. Water used in toilets, shower, baths, kitchen, sinks, or laundries in homes and office is domestic wastewater. There are three types of wastewater: domestic sewage, industrial sewage, and storm sewage. Basic characteristics of wastewater are physical characteristics. Color. Fresh sewage is normally brown and yellowish in color, but over time becomes black. Order. Wastewater includes sewage, typically develops strong odor. Temperature. Due to more biological activity, wastewater will have high temperature. Turbidity. Due to suspended solids in wastewater, it will have higher turbidity. Chemical characteristics. Wastewater contain different chemicals like COD, chemical oxygen demand. It is a measure of organic materials in wastewater in terms of oxygen required to oxidize an organic material. TOC, total organic carbon, in a measure of carbon within organic materials. Other elements such as chlorine, nitrogen, phosphorus, heavy metals, copper, silver, nickel, etc. are present. Analyzing both physical and chemical characteristics plays an important role in water waste treatment processes. BOD Biological characteristics. Biochemical oxygen demand is an amount of oxygen needed to stabilize organic matter using microorganisms. NOD Nitrogen oxygen demand. It is an amount of oxygen needed to convert organic components and ammonia, nitrogen to nitrates by nitrifying bacteria. Wastewater contains following microorganisms like bacteria, fungi, algae, protozoa, viruses, etc. Oil and grease. Oil and grease originate from food waste and petroleum products. An amount of oil and grease in raw wastewater varies from 10 to 109 milligrams per liter. Introduction water discharge. Introduction from any source, directly or indirectly, of non-domestic pollutants treated or untreated into district water waste treatment system. The term discharge is either discharge or removal of single pollutant or multi-pollutant. Below is the water waste discharge standard of various countries. Water waste treatment management. What wastewater treatment? What does a wastewater typically remove? Biochemical oxygen demand, nitrates and phosphate, pathogens, metals, total suspended solids, total dissolved solids, synthetic chemicals. Sewage wastewater. It is a type of treatment aims to remove contaminants from sewage to produce effluent suitable to discharge environment or intended reuse application. Primary treatment. Wastewater is held in settling tank where heavier solids sink to the bottom while lighter solids float to the surface. Secondary treatment. Degrade biological content of waste through aerobic biological processes. It reduces biodegradable contaminants. It's done by three ways. Biofiltration uses contact trickling filters to remove additional sedimentary waste. Aeration is a process increases oxygen saturation by introducing air to wastewater. Oxida- Oxidation ponds. Typically used in warmer climates, it utilizes natural bodies of water, lagoons, allowing water to pass through set period before retained for 2 to 3. Industrial wastewater. It is described as the processes used for treating wastewater that is produced by industries as an undesirable byproduct. After treatment, the treated industrial wastewater may be reused or released to a sanitary sewer or a surface water to a surface water in the environment. Some industry facilities generate wastewater that can be treated in sewage treatment plants. Most industries processes, such as petroleum refineries, chemical and petrochemical plants, have their own specialized facilities to treat wastewater so that the pollutant concentrations in the treated wastewater comply with the regulations regarding disposal of wastewater into sewers or into rivers, lakes, or oceans. This applies to the industries that generate wastewater with high concentrations of organic matters, toxic metals, toxic pollutants, or nutrients such as ammonia. Some industries install a pre-treatment system to remove some pollutants and then discharge the partially treated wastewater to municipal sewer systems. Most industries produce some wastewater. Recent trends have been to minimize such production or to recycle treated wastewater within production processes. Some industries have been successful at redesigning their manufacturing processes to reduce or eliminate pollutants. Source of industrial wastewater include battery manufacturing, chemical manufacturing, electric power plants, food industry, iron and steel industry, metal working, mines and quarries, nuclear industry, and etc. Treatment processes include brine treatment, solid removal, example chemical precipitation and filtration, oil and grease removal, removal of biodegradable organics, removal of other organics, removal of acid and alkalis, and removal of toxic materials. Agricultural water waste. Agricultural water waste treatment is a farm management agenda for controlling pollution from confined animals operations and from surface runoff that may be contaminated by chemicals in fertilizers, pesticides, and animal slurry, crop residue, or irrigation water. Agricultural wastewater treatment is required for continuous confined animal operations like milk and egg production. It may be performed in plants using mechanized treatment units similar to those used in industrial waste, where land is available for ponds, settling basins, and facultative lagoons may have lower operation costs. For seasonal use conditions from breeding or harvest sites, animal slurries are usually treated by contaminant in anaerobic environment before disposal by spray or trickle application to grassland. Constructed wetlands are sometimes used to facilitate treatment of animals. Non-point source pollution includes sediment runoff, nutrient runoff, and pesticide. Point source pollution includes animal waste, silage liquor, milking parlor waste, slaughtering waste, vegetable washing water, and fireworks. Many farms generate non-point source pollution from surface runoff, which is not controlled through a treatment plant. Leachate treatment. Leachate treatment plants are used to treat leachate from landfills. Treatment options include biological treatment, mechanical treatment by ultrafiltration, treatment with active carbon filters, electrochemical treatment, including electrocoagulation by various proprietary technologies, and reverse osmosis membrane filtration using disk tube module technology. Unit operations. The unit processes involved in wastewater treatment include physical processes such as settlement or flotation and biological processes such as oxidation or anaerobic treatment. Some wastewater require specialized treat, treatment methods. At the simplest level, treatment of most wastewater is carried out through separation of solids from liquids, usually by sedimentation, by progressively converting dissolved materials into solids, usually a biological floc or biofilm, which is then settled down or separated in an affluent stream of increasing purity is produced. Phase separation. Phase separation transfers impurities into a non-aqueous phase. Phase separation may occur at an intermediate points in a treatment sequence to remove solids generated during oxidation or polishing. Grease and oil may be recovered from for fuel or saponification. Solids often require dewatering of sludge in a wastewater treatment plant. Disposal options for dried solids vary with the type and concentration of impurities removed from water. Chemical oxidation. Advanced oxidation processes are used to remove some persistent organic pollutants and concentrations remaining after biochemical oxidation. Disinfection by chemical oxidation kills bacteria and microbial pathogens by adding hydroxyl radicals such as ozone, chlorine, or hypochlorite to wastewater. These then hydroxyl radicals then break down complex compounds into organic pollutants into simple compounds such as water, carbon dioxide, and salts. Anaerobic treatment. Wastewater treatment processes, for example, UASB, PGSB, are also widely applied in the treatment of industrial wastewater and biological sludge. And lastly, polishing. Sewage water treatment. Polishing refers to the treatments made in the further advanced treatment steps after the above methods. These treatments may be used independently for some industrial wastewater. Chemical reduction or pH adjustment minimizes the chemical activity of wastewater following chemical oxidation. Carbon filtering removes remaining contaminants and impurities by chemical absorption into activated carbon. Filtration through sand or chemical carbonate or fabric filters is the most common method used in municipal wastewater treatment. The above is the image of clarifiers that are widely used for wastewater treatment. This is an image of primary settling tank of wastewater treatment plant in Dresden, Cadets, Germany. This is a small secondary clarifier at a rural sewage treatment plant is a typical phase separation mechanism to remove biological solids formed in a suspended flow or fixed film bioreactor. Thank you.